And go.
Okay, I'm Dan.
I'm Chance.
And I'm Corey. You'll see me in a minute.
Hi, what we're doing is we're doing a program for a VFD and a PLC to a three-phase motor. This is our program on here that we've used. It's a pre-existing program. We just had to go in to our data files and change the speeds to what we want. Yeah, ramp up is 15 seconds, run is 10 seconds, ramp down is 5 seconds. This is the paper that we have to follow, and the guidelines that we have to follow.
Your velocity profile.
Huh? Should we go in? Is that it?
That's basically it. And then go over to Chance. And he's going to explain the wiring.
So, pretty much the wiring is really easy to follow, as long as you follow it. Right here I got the PCL VFD wire connections, the output from the PLC. Actually, I do have the L1, L2 and the ground coming in. It would be nice to have overcurrent protection on both, just in case something blows up. Output 1 goes to 0,1 on the VFD, output 2 goes to 0,2 on the VFD, and the AC DC 1 goes to number 11 as our stop signal. And then we do have L1, L2, L3 coming out of the VFD for a motor with the ground. We are using a card, which is controlling our analog signal for the ramp up and ramp down.
Yeah.
And that's, 0 to 13 and common to 14. Not too complicated. Our PCL input wire for the stop, start, and part sensor, proximity sensor. We're using 24 volts in. Hit the stop button, and that goes into in 0 on your PLC. The start 24 in will go into in 1 on PLC, and the part sensor, the sensing wire will go in 2. And just so you guys got a picture of our sensor, we got the brown, black, and blue wires and where they go to. So this is not too complicated. Just all right, Corey, it's all you.
All right. I got 2.5 minutes. Alright, to program this, we had to set, since our velocity profile said we had to have a decel time of 8 seconds when we hit the stop button, I changed our P42 for the maximum decel time to 8 seconds. And then went into our P45, changed it to parameter 0 for a ramp with a clear fault. P46, we use the terminal block as our start source, so I changed that to parameter setting 2. The speed reference, we were using the 0 to 10 volt input and 5, and that is wired into our input 13 and 14 for our 0 to 10 and our analog common. And up here is the wire in for 1, wire in for 2 for start run forward. We had to change a little bit. In the beginning we had a problem with our we had DC brake or DC injection at the beginning of our program. We changed our A436 to 0, so we had no DC brake current injected. We also had to change our T062 to a 49 and our T063 to a 51 to get everything to work with the program. We also went in and changed our A548, if I remember correctly. We set the reaction to a loss of power. It was on coast, which gave us some problems there in the beginning. We set that to decel, so we got what our program said and what our velocity profiles gave.
So what's this thing going to do, Corey?
So we got our stop button 1, it's normally closed, as they all should be. And we got our input 0. We got our proc switch here, and we're just using a little bit of metal on this toggle switch. That's going to give us our input 2. Now we're just waiting for a start signal to go into input 1 here. So once we get that, we're going to send output signal 1 and 2 into these 2 wires here, and that's going to start up our variable frequency drive. And this is our analog output card that's going to give us our signal for our ramp up and ramp down based on the program parameters. So I'm going to go ahead and hit start. We'll get our 15-second startup time to full hertz. And now it's going to ramp down. And then it's going to ramp back up, taking 15 seconds to get to full startup time, or full hertz.
It's a 60.
60.
Alright.
If you're in America. And then once we hit this, it's going to take it's going to take 8 seconds to get from 60 hertz all the way down to 0. And that's it.